Hi everyone, we're going to graph these two functions and test for continuity at x equals 1. So the first thing we're going to do is test for continuity here. And let's look at the definition of continuity. The first condition must be met, and then the other two need to follow as well. So all three conditions must exist. In our case, for both of these, our C equals 1, because that's where all the things are happening. And also remember here, this is the one that's x not equal to 1. So if x can't be 1, that means x is smaller than 1 or x is greater than 1. Alright, so the first thing we need to know is for this one, our C, and for both of them actually, our C is 1, so we're going to test f of 1. Well, f of 1 is negative 2. So it does exist, so we can check that one off. So condition 2, that means we have to test the limit here as as x approaches 1 from the left. That means this portion. That should equal the limit as x approaches 1 from the right. And that's this portion. So all you do is you plug in the 1 into this, and when you plug in for this one, you get e to the first power, which is e. And for this one, you plug in 1, you get e to the first power. So they do equal. So that means condition 2 is satisfied. Now, the condition 3 means that these values, so our limit as x approaches 1 of f of x, that equals e. However, our limit, or our f of c, equals negative 2. Since these two don't match, that means condition 3 is not satisfied. Alright? So I'm going to leave it to you to do this one. You're going to get the same situation. It's very similar. Alright? And now we'll graph these. Whoops. Alright. So you should know how to graph e to the x. So at 1, this is our critical point, it equals negative 2. So there's a point there. But if I plug in 1 in here, 1 e to the first power. So if I write x and then e to the x, do a little table here. If I plug in 0 for x, then e to the 0 equals 1. So there's that. Now I need to plug in 1, see what's going on with that. So if I plug in 1, get e to the first power, which is 2.718, close to 3. So at 1, we go close to 3, but it's going to be an open interval. Alright, now let's plug in 2, so that's going to be e squared. So it's going to be kind of close to 9, maybe 8. So we'll get it up in there. And it doesn't. So you already know what e to the x looks like, you should, by the time you get to these. So, and if you plug in negative 1, you get e to the negative 1, which is 1 divided by 2.718, which is 0.37. And whatever you plug in, it's just going to get closer and closer to the horizontal asymptote, y equals 0. And so that's what that looks like. And what you have here is called a point discontinuity. That's why it failed condition 3. Alright, because it's continuous, keeps going, it keeps going, but right here it jumps to this point. Then you have to go back up to come back up to here. Alright, and let's quickly graph the other one. So it's negative 2 everywhere but 1. At 1, let's do this one first. At 1, it's e to the x, which is just 2.718. So that's solid. But at numbers smaller than 1, it's negative 2. So I'm putting negative 2 here. So I'm going to do open interval here. And remember, this is your y values. So this is like saying y equals 0x minus 2. So that means it's a constant function. So everywhere at negative 2, it's going to be like that. It's going to keep going. So that's that graph. And you have that open interval there. So this is also called a point discontinuity. Because it jumps kind of to a point. And that's it. Thank you. Have a nice day. Bye-bye.